that these instructions would actually modify. The program takes it in via database based upon whatever chromosome is in the table over on the left here, and it's pretty much done all the work for you behind the scenes, making those insertions and deletions already. So you should be able to click on the Download Updated FASTA button here, and you'll get a file, an FA file back that you should be able to use for your research purposes. Hello and welcome to the overview of the Staff Scheduler project. This project was commissioned by Professor Deal so that scheduling meetings between professors at Endicott College would be a whole lot easier. So to do this, we'll start by filling in the left text box over here of what year and semester it is. So for example, spring of 2022, you'll click here to find the course schedule. It will build a alphabetical list of all the professors and the times they're kind of teaching and their schedules that year, and you're kind of able to scroll through this, and obviously you'll see all the professors. From here, you can kind of choose what professors you'd like. So for example, let's say we take this professor, these two, and then let's say these two up here, for example. And then after doing that, you're able to specify a time frame. So basically, you'll just kind of put in when you're looking for a meeting. So let's say you're looking for a meeting from 10 o'clock to about 5 o'clock. You'll kind of generate a schedule from here, and you'll see the schedule for the professors. So this is on Monday. You can cycle through these, and it'll kind of give you when they're available and when they're not. So obviously, if it's outlined in red, you're in class or teaching or doing something at that point, and you'll able to kind of see in this time summary table on the right how available those times are. So yellow kind of demonstrates that maybe some can't make it, while orange and full red will kind of indicate that there's a lot of professors that can't meet it. And again, you can kind of cycle through this table. So if you were looking for, let's say, Thursday, you can see that there's a lot more available times, and this kind of just cycles all the way around, and you can see when professors are open or not. You're able to also add professors onto this. So for example, if we want to generate another one, we can have another person added onto this list, or we can take a whole bunch of people off if that's something you'd like to do too. Maybe we update this to 5:30, and we can kind of see the updated graph. Again, cycle through. And yeah, this should make it a lot easier to schedule meetings between professors. Hello, and welcome to the overview of the Google Play App Helper project. This project was done for Professor Yang, so you can be able to scrape the Google Play Store and filter out its apps based upon your preferences, and this program here will kind of help you clean up that data for other research purposes. So to first do this, you must obtain a usable CSV file. To do that, you'll be able to click here if you access this page to download ParseHub and import my project. That pretty much allows you to scrape any filtered out app page that you would like. After that, you're able to upload the CSV file into this program. Let me do that right now. And once you do this, you'll kind of see a table of everything that was scraped. So this includes names, ratings, descriptions, the price if it comes with one. From there, you're able to kind of modify this based upon the buttons right up top here. So sometimes Excel has some strange characters that it can't render, and if you're posting, let's say, the descriptions into, some type of reader to try to like search through characters and words and things like that, you don't really want to see weird characters and stuff like that. So as you can kind of see when we click on this button, you might see it already when it just updates here. It's very minuscule. Basically, it'll just kind of update and remove all characters that Excel really isn't able to read. The next button that we're able to use here is description word count. This is a pretty basic one. If you want to know how many words are in each of the descriptions, you can click the description word count button, and it will add it to this table. The final button we have is a check for privacy. So upon clicking this, you'll kind of see the extracted text of the privacy policy. So for example, you can kind of see it's roughly in here, and it's now been taken roughly over here. And this also checks if it has it or not. So for example, the one below here doesn't have anything about a privacy policy, so it did not list it. From there, once you're happy with your data, you can use as many of these options as you would like. You're able to download the Excel sheet, and it'll look just exactly like the one that you see here, reformed back into anything that you can really plug in for research. Hello and welcome to the overview for the confidence intervals project. This project was developed for Professor Lombardo and is used to simulate statistical data. On the left over here, you can see the generated random plot of points. These will add up to roughly a mean of 12. And what you're able to do with the simulator is you're able to take an amount of samples from the left side, perhaps we say 20, and calculate the mean of those on the right and see if it's inside the error margin. Say we make an error margin of 0.8. Take one sample, and we'll see that it was inside. If we take 50 samples, we'll see that there was a whole bunch of different values, some red and some blue. If you kind of want to see how far away these are inside the error margin, you can click on Show Confidence Interval, and it'll kind of bring up these lines to show you roughly how these match up inside the error margin. You're able to reset the simulation and try again with a different amount of size. So if we take a whole bunch of samples with a really low error margin, we take a bunch of samples, data changes. And you can kind of see the success rate down at the bottom and see what values you can play with to get highest success. Hello and welcome to the overview of the mean comparison project. This is another project from Professor Lombardo that goes over different types of data and how the differences of means change based upon it. So as you can kind of see on the left, we have a panel of mean populations, and as you kind of change these, you'll see that the values in the top graph change. You can see that the blue represents the data values of population A, while the mean of population B is highlighted in this reddish orange color. Based upon the difference of these, you can take an amount of samples from each and see what you get in terms of a distribution. And when you do this, do it a couple times or either 100 times, and you'll see kind of exactly where it lines up. So the difference between these two is roughly 20, and you'll kind of see that around this mean line, most of the values are around that as well. And you're able to change and reset these as well and take a different amount of samples, and you're going to find out that obviously the more samples you take, the more accurate data you will get, but you're generally still all around the same line. You're also able to change these, make them more even, and you'll see kind of how close they are as well. Obviously on the top, most of them are overlaying. Pretty much no matter how many samples we take, we're going to get something really close to 0. Hello and welcome to the overview of the central limit project. This is the third project that I did for Professor Lombardo. It kind of simulates different types of data models and how the distribution of means is calculated based upon those. So kind of on the left here, you see we have different types of models. For example, we have normal, right skewed, left skewed, uniform, and bimodal, and you can kind of see how the top graph changes and shows roughly where the mean is on all of these. These are not randomly generated, they're inserted into the backend, but it kind of works for any data model that's very similar to those. We'll take any type of sample size, let's say we take 150, and we're able to check what the distribution of these means should be. It should be right under the green mean line, as you can see at top. And if we go and check, take 100 samples, and that's roughly what we get. You can kind of change this with any of them. So if you went to use left skewed per se, and let's say maybe we only even took 120, we're still going to see a lot of samples right under where the mean line is.